Hi, my name is Suraj Singh. I am one of the mentors at Programming Pathshala. I am expert on Codeforces and 5-star on Codechef. Today we are going to discuss this problem called coin combinations 1. And the problem statement says that we will be given with n values of coins and we have to find out the distinct number of ways to produce a sum of money equals to a given value x using those n values of coins, right? And to understand the problem statement, we are given with an example where n is equals to 3 and x is equals to 9 and the values of coins are 2, 3 and 5. Right? Now we have to find out how many distinct ways are there in which we can get a sum of 9 using these 3 values of coins, right? And according to the problem statement, these are the 8 ways in which we can get a sum of 9 using these 3 values of coins, right? Now if we just look at all these ways, they sum up to 9, which is a bit obvious. But we can observe 2 more things from these 8 ways. First is that we can use the same value of coin multiple times, right? We can use the same value of coin more than once. And second thing which we can observe from these ways is that we have to consider different permutations as different ways. So if we just look at these 3 ways are just a permutation of each other, right? They just are permutation of this combination, which is 2 coins with value 2 and 1 coin with value 5, right? So we have to consider all the different permutations as a different way of getting a sum, right? So now problem statement is clear, so we can try to take an example and try to figure out how we can solve or approach this problem. So let's take the same example which is provided in the problem statement where n is equals to 3 and x is equals to 9, or we can say the desired sum is 9. And the values of coins are 2, 3 and 5, right? Here we want to find out the total number of distinct ways to get a sum of 9 using these 3 values of coins, right? And to get a sum of 9, we will pick some number of coins, right? And while picking a coin, we have 3 options. We can either pick a coin with value 2 or a coin with value 3 or a coin with value 5. So let's try to explore these 3 possibilities, right? So we want a sum of 9. And the first possibility is that we can pick a coin with value 2. Okay, so now we can say that we wanted a sum of 9, and if we pick a coin with value 2, in that case the remaining value will be 7, right? And here we would want to find out the total number of distinct ways in which we can get a sum of 7. Why? Because if we know all the ways in which we can get a sum of 7, then in all those ways we can add 1 coin with value 2 and we'll get a sum of 9. For example, we can get a sum of 7 using 2 coins with value 2 and 1 coin with value 3, right? These 3 coins add up to 7. Now what we can do is we can simply add 1 more coin with value 2 and the sum of all these 4 coins will be 9, right? Okay. So we can say that finding out all the distinct ways to get a sum of 7 can eventually help us in finding out all the distinct ways to get a sum of 9, right? Okay. So now if we just talk about the second possibility in which we can pick a coin with value 3, in that case the remaining value will be 6. And if we pick a coin with value 5, in that case the remaining value will be 4, right? So here we want to find out total number of distinct ways in which we can get a sum of 7. Here we want to find out the total number of ways in which we can get a sum of 6 and total number of ways in which we can get a sum of 4. Okay, cool. So now to get a sum of 7, again we have 3 options. We can pick a coin with value 2, 3 or 5. So if we pick a coin with value 2, in that case the remaining value will be 5. And if we pick a coin with value 3, in that case the remaining value will be 4. And if we pick a coin with value 5, in that case the remaining value will be 2, right? Okay. Again for 5 we have 3 options. We can either pick a coin with value 2, in that case the remaining value will be 3. Or we can pick a coin with value 3, in that case the remaining value will be 2. Or we can pick a coin with value 5, in that case the remaining value will be 0, right? Okay, now for 3 again we have 3 options. We can either pick a coin with value 2, in that case the remaining value will be 1. Or we can pick a coin with value 3, in that case the remaining value will be 0, right? Now we have an option to pick a coin with value 5. But we require a sum which is 3, which is smaller than 5, right? So if we pick a coin with value 5, in that case we will require a sum of minus 2 to get a sum of 3. See, we wanted a sum of 3, but we got a coin with value 5. We wanted a sum of 3, we got a coin with value 5. So in that case, what sum we require such that it becomes equals to 3? So we can say we will require a sum of -2, right? And because the values of coins will be non-negative, in that case we can say it will be impossible to generate. We will never be able to generate a sum of -2 using any value of coin. Okay, so we can say it is impossible, right? Similarly, we can say it will be impossible to generate a sum of 1 also using these 3 values of coins. All right. So again, for 2, we can say that we can pick a coin with value 2. In that case, the remaining value will be 0. And if we try to pick any other coin, in that case, it will be impossible to generate a sum of 2. So we can skip that for now. Okay. So similarly, we can complete this whole tree of possibilities. And after completion, it would look something like this, right? Okay. Now we have already discussed that it will be impossible to generate a sum of 1, and it will be impossible to generate a sum of -1 using these 3 values of coins. So in that case, we can say that there will be 0 number of ways to get a sum of 1, and there will be 0 number of ways to get a sum of -1. And because of this, we can say that we will have 0 number of ways to get a sum of 3 if we pick a coin with value 2, or we pick the coin with value 5, right? So in both the cases, there will be 0 number of ways to get a sum of 3. But now what about 0? In how many ways we can get a sum of 0? So we can say that there is one way to get a sum of 0, and that is to not pick any coin, right? So in that case, we can say that there will be one way to get a sum of 0. And because there is one way to get a sum of 0, and that is to not pick any coin, then we can say then there is one way to get a sum of 3 if we pick a coin with value 3, right? So from this possibility, we can say there is one way to get a sum of 3, okay? Now, because there is one way to get a sum of 3, we can say there will be one way to get a sum of 5 if we pick a coin with value 2. Because in this way, we can just add one coin with value 2 and we'll get a sum of 5, right? So because we had one possibility or one way to get a sum of 3, we can say that there will be one way to get a sum of 5 if we pick a coin with value 2, okay? So now let's focus on this part. So here also we can say there is one way to get a sum of 0, and that is to not pick any coin. And because there is one way to get a sum of 0, we can say there will be one way to get a sum of 2 if we pick a coin with value 2, because 0 plus 2 is equals to 2. And now because there is one way to get a sum of 2, we can say there will be one more way to get a sum of 5 if we pick a coin with value 3, and that will be just add this coin to the number of ways in which we can get a sum of 2, okay? So we got one way to get a sum of 5 if we picked a coin with value 2, and again we got a one way if we picked a coin with value 3. Now let's see this part. So here also we can say that there will be one way to get a sum of 0, right? And because there is one way to get a sum of 0, we can say there will be one more way to get a sum of 5 if we pick a coin with value 5, right? Okay, so we got one more way to get a sum of 5 if we picked a coin with value 5, right? And similarly, we can find out the number of ways for all the values which are present in this tree, okay? So let us just calculate for the 7 also. So here again we have one way to get a sum of 0, and because we have one way to get a sum of 0, we can say that there will be one way to get a sum of 2, that will be 0 plus 2, right? And because there is one way to get a sum of 2, we can say there will be one way to get a sum of 4 if we pick a coin with value 2, right? So from here we got one way, and now we can say there will be 0 number of ways to get a sum of 1, and because there are 0 ways to get a sum of 1, we can say we will have 0 number of ways to get a sum of 4 if we pick a coin with value 3. So in that case, we can say there is only one way to get a sum of 4, okay? Now because there is one way to get a sum of 4, we can say there will be one way to get a sum of 7 if we pick a coin with value 3, and that will be 2. Just add this 3 to this way of getting 4, right? And from this possibility, we can say if we picked a coin with value 2, in that case, we can say there will be 3 ways. How? See, these are the 3 ways to get a sum of 5. Now what we can do, we can just add one coin with value 2 in all these 3 ways, and we'll get a sum of 7 from all these 3 ways, right? So we got 3 ways to get a sum of 7 if we picked a coin with value 2, right? Okay, so we have talked about this part and this part. Now let's talk about this possibility. So again, we can say for 0, we have one way to get a sum of 0. Now, because there is one way to get a sum of 0, we can say there will be one way to get a sum of 2, right? If we pick a coin with value 2. And now, because there is one way to get a sum of 2, we can say there will be one more way to get a sum of 7 if we pick a coin with value 5. Okay, so we got one way from here, and three ways from this possibility. Then we can say in total we got 5 ways to get a sum of 7, right? And similarly we can find out number of ways for all the other values. Okay, cool. So now if we just look at these 5 ways, then we can say that all these ways start from a value which is 0, right? And if we just focus on this way, then we can say that this represents that we started from 7 and we got a coin with value 2, then we got a coin with value 2, then we got a coin with value 3, and then finally we reached a value which is 0, right? And similarly, if we look at this way, then this represents that we started with 2, then we picked a coin with value 3, then we picked a coin with value 2, and again we ended at 0, right? And similarly, for this way, we can say we started from 2, then we picked a coin with value 5, and we finally landed at a node which is having value 0, right? So can we say that all these ways are nothing but a way or a path starting from this 7 and ending at a node with value 0, right? Because we have 5 ways, and in all those 5 ways we are ending at a node which is having a value 0. So first, second, third, fourth, and fifth, right? So all these ways can be represented by these 5 paths. Okay, cool. So we can say that the number of ways to get a sum of 7 is nothing but the number of paths that start from 7 and end at a node with value 0, right? So we are basically just counting such paths. Okay. Now we have one question, like all these paths are distinct, but why they are distinct? And will it always happen, like will we always get distinct paths, or there can be some duplicates? So although we should have asked this question to ourselves even before coming up with this tree, but just to understand, we are asking this question right now. Okay, so maybe now you can pause the video and think that why we are getting distinct ways, and will we always get distinct ways or not? Okay, so we will just focus on 7 for now, because we already have the number of ways to get a sum of 7, right? Okay, so for getting a sum of 7, we had these 3 possibilities. First one was to pick a coin with value 2, and second one was to pick a coin with value 3, and third one was to pick a coin with value 5, right? Now we want to know that will all these possibilities generate a distinct way, or there can be some duplicates, right? This was the question. Okay, so now can we say that if we pick a coin with value 2, then we will have this subtree of possibilities, and whatever way that we will get from this subtree, all those ways will start with a coin with value 2, right? So after this we will have some number of coins, but we will start with 2, right? And if we pick a coin with value 3, then this will be the subtree of possibilities, and whatever way that we will get from this subtree will start with value 3, right? And similarly from this subtree we will get some number of ways, and all those ways will start with a value 5, right? Okay, now can we say that all the ways that start with the value 2 will be different than all the ways that start with value 3 or with value 5, right? Like even if we do not look what we will get after this, we can say that they will be distinct, just like here. So all these ways start with the value 2, and all these ways start with value 3, and all these ways start with value 5. So just by looking at the first value, we can say that all these ways will be different than the ways that start with 3, and also different from all the ways that start with value 5, right? So we can say that we will get distinct ways if these values are different, right? 2, 3 and 5 are distinct values, right? Okay. Now we can have a follow-up question that could be that what if we get duplicate values in this values of coins? What will happen in that case? So we know that there will be some problem, right? So now you can think that how we can resolve that problem, and in that case, how we can find out distinct ways, right? And although in the problem statement it is not mentioned, but we will receive distinct values of coins only. Okay. So for now we can move ahead, but you can think about it, and if you want we can discuss it in comment section. Okay, cool. So for now we will move ahead. Okay, so from this tree of possibilities, we can again observe two things. First one is that the problem definition will remain same, because here we wanted to find out the distinct number of ways to get a sum of 9, and here we wanted to find out the distinct number of ways to get a sum of 7, and here we wanted to find out the distinct number of ways to get a sum of 6, and similarly here we wanted to find out the distinct number of ways to get a sum of 4, and similarly for all these values we just want to find out the distinct number of ways to get a sum of particular value. Okay, cool. So the problem definition is same and the size is reducing. So because the problem definition is same, we can use the same function to calculate the answer for all these values, and because the size is reducing, we can write that function in a recursive manner. Okay, so now we can try to think of a recursive relation for this problem. Alright, now for recursive relation we need a function f of x which can return us the distinct number of ways to get a sum of x using the given n values of coins, right? And in this example x is equals to 9, so that means we need to find out the value of f of 9, right? And we've already seen for this we have three options. We can either pick a coin with value 2, or we can pick a coin with value 3, or we can pick a coin with value 5. So if we pick a coin with value 2, in that case the remaining value will be 7, because we are trying to generate a sum of 9, and if we will get a coin with value 2, in that case the remaining value will be 7. And now what we want to do? We want to find out the distinct number of ways to get a sum of 7 using these three values of coins. So for that also we can use this same function, because this function will return us the distinct number of ways to get a sum of x. So we can call this function for f of 7, right? Similarly, if we pick a coin with value 3, in that case the remaining value will be 6, and we would want to find out the distinct number of ways to get a sum of 6. So we can call this function for f of 6, right? And similarly the last option is to pick a coin with value 5, and in that case the remaining value will be 4, and we can call this function for f of 4, and it will return us the distinct number of ways to get a sum of 4, right? Okay. Now let's say there are x number of ways to get a sum of 7. So can we say in all those x ways we can just add one coin with value 2 and we will get a sum of 9, right? So if we pick a coin with value 2, in that case we can say we will have x number of ways to get a sum of 9, and let's say there are y ways to get a sum of 6. In that case we can say if we pick a coin with value 3, then there will be y more ways to get a sum of 9, and let's say there are z number of ways to get a sum of 4. Then we can say that if we pick a coin with value 5, then there will be z more ways to get a sum of 9, right? Okay, now let's try to generalize this recursive relation. So for f of x, we will have n number of options, right? We can pick a coin with value a of 0, a of 1, or so on till a of n minus 1. Here I am assuming that this array which contains the values of coins have a name a, right? So we will represent this array by name a. So for this we have first option, which is to pick a of 0. In that case we will call for f of x minus a of 0, right? And second option is to pick a of 1. In that case we will call for f of x minus a of 1, right? And so on. The last option could be to pick a coin with value a of n minus 1. In that case we will call f of x minus a of n minus 1, right? Okay. Now the distinct number of ways to get a sum of x will be equals to the sum of all these values that we'll get after making all these recursive calls, right? And this recursive relation will be valid for all the values of x greater than 0. For x is equals to 0, we know there is one way, right? So whenever x is equal to 0, we know the number of ways is 1. And if x is smaller than 0, in that case the number of ways is 0, right? So this is the recursive relation. Okay, now we can try to code this. Okay, so let's have a function called solve, and we will pass x as a parameter, and because we need to return the distinct number of ways to get a sum of x, the return type of this function should be integer, right? Okay, so now let's take care of the base cases first. So if x is equals to 0, in that case we need to return 1, because in that case we have one way to get a sum of 0. And if x is smaller than 0, in that case the number of ways are 0. Okay. Now if these two conditions are not true, in that case we need to follow this recursive relation, and for that we need to make all these n function calls, right? So to make all these n function calls, what we can do is we can run a loop starting from 0 till n minus 1, and we can keep on calling all these functions, right? So let's have a for loop starting from 0 and going till n minus 1, right? And we can make these function calls f of x minus a of I, right? Now it will return the distinct number of ways to get a sum of this value, right? Now what we have to do is we have to keep on adding whatever values they will return. So let's have a variable in which we can store that. So it will be initialized with 0, and we can keep on adding whatever these functions will return. So after this for loop, we can say for sure that this variable ans will have the distinct number of ways that are required to get a sum of x. So we can simply return ans after this for loop, right? So if we talk about the time complexity, then we can say it will be exponential, because we'll call f of x, and f of x will make around n function calls, and all those n function calls will make around n more function calls, right? So this will grow exponentially, right? So if you want to discuss the exact time complexity, then we can do that in comment section, but for now we can assume that it will have a exponential time complexity, right? So now let's try to see if we can optimize this code or not. Okay. Now I have drawn this recursive tree for this given example, which we have already talked about, right? So the recursive tree would look something like this. And from this tree, we can observe few things, like there are some calls which are made again and again. For example, if we just look at f of 4, so f of 4 is called here, f of 4 is called here also, and here also. Similarly, f of 3 is called here, f of 3 is also called here, and f of 2 is also called multiple number of times, right? So we can say there are some calls which are made again and again. Now let's just talk about f of 4. So when we are at this function call, what we want to calculate? So we want to calculate the distinct number of ways to get a sum of 4, and for that what we'll do, we'll make some function calls and we'll calculate the answer. But when we will be at this function call, in that case also we will make the same number of function calls, and again we will calculate the same thing, right? Similarly here also we will calculate the same thing, right? So instead of calculating the same thing multiple times, what we can do is, when we are at this f of 4, we can calculate the answer and we can store it somewhere. Let's say the answer for f of 4 is a. And when we are at this function call, or when we are at this function call, at that time, instead of making all these calls again, what we can do, we can just use this value which we have already calculated and stored. So instead of making these calls, we can simply return a, and here also we can simply return a, right? Similarly, for other calls also we can do the same thing, right? Okay. Now there is one more thing which we can observe from this recursive tree, and that is that all these function calls have values between 0 to 9, right? Because the size of problem is keep on reducing, right? So here we have all the values between 0 to 9, although there will be negative values which will be handled using this condition. But other than that, we can say all the function calls will have values between 0 to 9. So now if we try to generalize this thing, then we can say for f of x, we will make a lot of function calls, and all those function calls will have values between 0 to x, right? That means we can say we will have x plus 1 number of unique function calls. For example, f of 0, f of 1, f of 2, f of 3, and so on till f of x. So we will have x plus 1 number of unique function calls. And to store all their answers, we will require an array or a vector of size x plus 1, right? So let's have a vector of size x plus 1. So let's say we have a vector dp of size x plus 1, and we can initialize this with -1 because we can never have -1 ways to get a sum, right? So -1, cool. Now in this recursive code, this is the part where we are finding out the distinct number of ways to get a sum of x. So before executing this, we can check if we already have the answer for this x or not. So if dp of x is not equals to -1, in that case we can say that we have already calculated the answer for this given value of x, and in that case we can return dp of x instead of calculating it, right? Otherwise, we can execute this part and find out the answer, and before returning, we can store it, right? So dp of x will be equals to ens, right? Okay, cool. So this will be the memoized solution for this. And if we talk about space and time complexity, then we can say that this part will have a time complexity of big O of 1 because we are just having if conditions, right? And this part will have a time complexity of big O of n because we are iterating from 0 to n minus 1. So this iterations will take order of n time, right? Okay. Now, how many times this part will be executed? So we can say that this part will be executed at most x number of times. Why? Because let's say once we calculate or execute this part for f of 4, then if we again encounter f of 4, in that case, we will not execute this part. We will just execute this if condition, right? So for every value of x, this part will be executed only once. So we can say that this part will be executed around x number of times. So the time complexity will be big O of x into n, and the space complexity will be big O of x. Because of this vector and also the recursive stack can never have a size greater than x, right? So time complexity and space complexity. Okay. Now, the number of ways to get a sum of x can be really huge. So problem statement says that we need to take a modulo with 10 power to 9 plus 7. So although we have not discussed that part here, but while taking sum, you can just take modulo also, right? If you found the video helpful, then do like, share and subscribe. And if you are looking to improve your problem solving skills and get 100% interview ready, then take a free trial on programmingpathshala.com. Link will be in the description.